So let's talk about event-driven architecture today. Quite a popular architecture pattern, specifically when you are doing cloud solutioning, you will encounter this pattern quite often, right? Now, in this particular pattern, all the application components or system components respond to events instead of a centralized command issued by a centralized service authority. And at the same time, in this architecture, each component does the processing asynchronously without depending on the other component itself. And then it is also basically capable of scaling individually, right? Now let's try to take an example and understand this, right? So let's say your use cases, you have to develop an analytics reporting tool, web application wherein the use cases you will have multiple long running reports, which is doing very heavy data lifting from a centralized data warehouse, and reporting needs are quite complex, which means that you will have to develop complex cross tab reports across millions of rows and columns on an Excel sheet or on an CSV, right? Now, customer also wants a capability to run this report generation for multiple such reports in parallel without blocking the UI, which means that there should be a fire and forget situation where customer submits the request and then move on to the next reporting, and then it is system's responsibility to basically generate the report and finally notify the end user, right? Now, let's try to come up with an architecture for such requirement. Let's talk about first the components. So, the very basic set of components which I can think of is you have a request acceptor component which accepts the request from the browser and then passes on the control to data extractor, right? So, data extractor is the component which runs heavy queries, complex queries against the data warehouse, pick up the data and then pass on the data to report generator, which finally runs a heavy business logic on top of this data and performs a processing to finally generate a cross-tab CSV report, right? And here browser basically is the client which initiates the request. Now, very simple architecture to this could be that you design a monolith container where all these components are sharing a chain of responsibilities, wherein one component completes its processing and pass on the control to the next component, right? As I said, as this component or as this architecture looks pretty simple, it has its own downfalls. What are those downfalls? When the number of request count is high, then you will basically seek scalability issues, because in this particular architecture, no component is basically free to individually scale, which means that if my data extractor has to scale, then the entire monolith container needs to scale, which is quite expensive and not so maintainable solution, right? At the same time, the factor to scale for each component could be different, which means that for a data extractor, the factor to scale could be the complexity of the query, right? While for a report generator, the factor to scale could be the number of rows and also the complexity of the reporting needs, which in this case could be a business logic, right? And therefore, all the components are tightly coupled and dependent on each other, which kills the scalability, of course. And then when the number of requests are high, then this particular channel, if you consider this as a REST or gRPC channel, would be overwhelmed, right? And more you have the more number of requests, more you have the number of threads open in the system memory, which also becomes a bottleneck after a point of time, right? Now, how do you solve this problem? So I think the first thing to do is you um, design these components as individual microservices, right? Which at least solves the scalability problem, which means that now each service based on its scalability factor can scale, right? And um, and then independently grow, right? And then there should be a gateway service in between, which acts as a mediator between these components, which coordinates the entire calculation effort, right? This solves the scalability up to an extent, but this architecture still has problems, right? Which means that again, when the number of requests are high, this particular channel will again get throttled, right? And at the same time, If your reporting needs are complex, if your reporting itself is complex, the coordination also becomes an overhead, right? And therefore, this architecture does not also scale, right? Now, let's talk about how do you really solve this with an event-driven architecture, right? So here, each component still remains as an individual microservice, but then they are not triggered exactly by a channel opened up between the services. Rather, you have bridge queues in between, message queues in between, which acts as a trigger point for each component. What does that mean? So let's say there is a request of a report generation, which basically goes to gateway service. And once this request has been accepted by gateway service, this particular request channel closes. Right. So it becomes asynchronous, wherein gateway service validates the request and then finally put a message into the message queue. Right. Now, this particular message queue is listened by data extractor component, which can take its own time to pick up this message from the queue asynchronously, scale individually, and then query the data from warehouse, and then finally put the results into a blob storage, right? Once data extractor completes this processing, it will again drop a message in the message queue, which is again polled by a report generator, which will pick up the message, again scale individually if needed, reads the data from the blob storage, and then completes the processing and put up data into blob storage back, right? Now, once report generator completes this, it will again drop a message for a notification service, which will pick up that message and identify that report generation has been completed. So it will be connected with the browser via a server side event keep alive channel, and then with which it will notify the browser that your download is basically ready. Right now, browser will basically um, present the link to download for the end user to download it from the blob storage. Right now, here, as you see, all the components are individually scalable. At the same time, processing is asynchronous, which means that there is no load on the system to manage multiple open threads, basically for the system. Also, this solves the throttling problem, right? Now, the question is, when these components are communicating with each other, how do you really form a basis for communication? Which means how do they share data, right? So for each step, you can also maintain a table in the database wherein you have individual columns for each stage where you can store the data for that particular component, right? And then this all could be tied up with a GUID which identifies that particular report transaction, right? Now, at the same time, you can also maintain a table where you record the individual status of each component while a particular transaction is going on. And at any point of time, if you find any failures or you need to replay the entire set of events, you can just replay it, right? So, yeah, this is how you basically solve the scalability and other problems basically with an event-driven architecture. Thank you.